Hi everyone, my name is Rishabh and I'm going to present you the topic measurement and testing of IC engines. So first let me give you the introduction of the topic. Engine performance is an indication of the degree of the success of the engine perform its assigned task. That is, the conversion of the chemical energy contained in the fuel into the useful mechanical work. Now, it is evaluated on the basis of the following parameters, which are specific fuel consumption, brake mean effective pressure, specific power output, specific weight, and exhaust smoke and other emissions. So, let us find the basic measurements. The basic measurement to be undertaken to evaluate the performance of an engine almost all the tests are speed, fuel consumption, air consumption, smoke density, brake horsepower, indicated horsepower and frictional power, etc. Now, let us do the measurement of speed. One of the basic measurement is that of the speed. A wide variety of the speed measuring devices are available in the market. They range from mechanical tachometer to digital and triggered electrical tachometers. So it is the best method for the measurement of speed. Now we have fuel consumption measurement. Fuel consumption of the engine is measured by determining the volume flow in a given time interval and multiplying it by the specific gravity of the fuel, which should be measured occasionally to get an accurate value. Now we have another method, that is measure the time required for the consumption of a given mass of fuel. It is quite simple. Now we have measurement of air consumption. In IC engine, the satisfactory measurement of the air consumption is quite difficult because the flow is pulsating. Now, due to the cyclic nature of the engine and because the air is a compressible fluid. Therefore, the simple method of using an orifice in the induction pipe is not satisfactory since the reading will be pulsating and unreliable. So, the various methods and meters used for the airflow measurement include airbox method and viscous flow air meter. Now we have measurement of brake power. The brake power measurement involves the determination of the torque and the angular speed of the engine output shaft. We have different torque measuring devices, and this is known as dynamometer. Dynamometer are broadly classified into different. They are power absorption dynamometer and transmission dynamometer. Now, absorption dynamometer. These dynamometer measure and absorb the power output of the engine to which they are coupled. They the power absorbed is usually dissipated as heat by some means. Example of such dynamometer is Prony brake, rope brake, hydraulic dynamometer, etc. Now, transmission dynamometer. In transmission dynamometer, the power is transmitted to the load coupled of the engine after it is integrated on some type of scale. These are also called torque meters. Now, measurement of friction power. The difference between the indicated power and the brake power output of an engine is known as the friction power. So friction power is equal to indicated power minus brake power. Now almost invariably, the difference between a good engine and a bad engine is due to the difference between their friction losses. Now we have different tests. Let us take the first test, that is Morse test. The Morse test is applicable only to the multi-cylinder engine. In this test, the engine is first run at the required speed and the output is measured. Then one cylinder is cut out by short circuiting the spark plug or by disconnecting the injector. Now in this test, the engine is first run at the required speed and the output is measured. Thus one cylinder is out by short circuiting the spark plug or by disconnecting the injector. Now we have indicated power. Well, we all know about indicated power. It is the power developed by the cylinder and is designated as IP. The IP of an engine at a particular running condition is obtained from the indicator diagram. The indicator diagram is the PV diagram for one cycle at the load drawn with the help of the indicator fitted on the engine. Now let us understand the fuel consumption. Two glass vessels of 100 cc and 200 cc capacity are connected in between the engine and the main fuel tank through the three-way cogs. When one is supplying the fuel to the engine, the other is being filled. The time for the consumption of the 100 or 200 cc engine is measured with the help of a stopwatch. Now, a small gas is attached to the main fuel tank as shown in the figure. When fuel rate is to be measured, the valve is closed so that the fuel is consumed from the burette. The time for a known value of the fuel consumption can be measured and fuel consumption rate can be calculated. Now, fuel consumption kilogram per hour, we have a formula for this. Volume into my specific gravity divided by 1000 into my time consumed. So now friction power. Friction power includes the friction losses and pumping losses. During suction and exhaust strokes, the piston must move against a gaseous pressure and power required to do this is called pumping losses. The friction losses is made up of the energy loss due to the friction between the piston and the cylinder wall, piston rings and cylinder walls, and between the crankshaft and the camshaft and their bearings, as well as by the loss incurred by the driving the essential accessories such as the water pump, ignition unit, etc. Now we have Willis line method. This method is also known as the fuel rate extrapolation method. In this method, a graph of the fuel consumption versus brake power is drawn and it is extrapolated on the negative axis of the brake power. Let me show you the diagram. It is something like this. So now the intercept of the negative axis is taken as the friction power of the engine at that speed. As shown in the figure, in most of the power range, the relation between the fuel consumption and the brake power is linear with speed of the engine is held constant, and this permits extrapolation. Further, when the engine does not develop power, that is brake power equal to 0. The main drawback of this method is the long distance to be extrapolated from the data between the 5 and 40% load towards the 0 line of the fuel input. As you can see here, the direction margin of the error is rather wide because the graph is not exactly linear. The performance of an engine is usually studied by the heat balance sheet. The main component of the heat balance are heat equivalent to the effective work of the engine, heat rejected to the cooling medium, heat carried away from the engine with exhaust gases, and unaccounted losses. Now the heat supplied to the engine is only in the form of the fuel heat, and that is given by MF into CV, value of the fuel. The various ways in which the heat used up in the system is given by heat equivalent of Vp is equal to we have a unit kilowatt, kilojoule per second or kilojoule per minute. Now heat carried away by the cooling water, it is equal to Cp into M, and the unit is kilojoule per minute, where MW is the mass of the cooling water in kilogram per minute or kilogram per second circulated through the cooling. And heat carried away by the exhaust gases is equal to the mass of gases into my Cp, which is whichever unit of kilojoule per minute or kilojoule per second, where mg is the mass of the exhaust gas, as I already told you. Now Tg is equal to the temperature of the burned gases coming out of the engine, and Ta is the ambient temperature, and Cpg is the specific heat of the exhaust gas in kilojoule per kilogram Kelvin. Now, thank you so much.